Okay, good morning class. So at this point we're looking at trigonometric graphs or trigonometry, trig graphs. I gave you guys some homework, correct? Sorry. The homework was 12B. Right, so this is worksheet 12B. They ask you to draw the graphs of the following on a different set of axes. We have two graphs there, so it's the sin x minus 1 graph and g of x equal to tan x. So the sin x minus 1, let's get a okay, so what's happening to the basic sine graph? What's happening to the basic sine graph? It's moving 1 unit down. So we know from the basic sine graph, somebody will just read the questions for us. As you can see, we need the space basically. Okay. Okay, so if we look at the basic sine graph, 0 is 0, 90 is 1, 180 is 0, 270 is minus 1, 360 is 0. So what we do is, that graph, draw this graph here, that graph we're going to move 1 unit. That's what the graph is going to look like. Not so? Morning. The graph move 1 unit up. But importantly, we write in the turning points and the end point. We're not on the axis. That is 270. And this is your 360. And this is your y equals sine of x. Okay, you all agree with that? Then they ask you to draw the tan of x graph, not so? Sorry? So minus 1. Oh, so you move 1 unit? No. Oh, I thought the sine of x plus 1. My mistake. So that's on an axis. That's also on an axis. And this here is going to be 270 and minus 2. It's going to be 360 and minus 1. Okay. So that is the y is equal to sine of x minus 1. Then they wanted you to draw the tan of x graph, no? So on a different set of axes, correct? Yes. So just draw another axis here quickly. I will have to delete it afterwards. Paste. Okay. So the tan of x graph goes into intervals of 45. So 0 is 0, 45 is 1. At least one of the points we draw, we write on the tan graph. 90 is in asymptote. So that's what the graph looks like. Comes close, doesn't touch, goes there, there. 270 is again in asymptote. 360 So let's look at the first question. What's the first question say? The period. So this is the g of x graph. Not so. This is the g of x graph. Alright. So what is the period of the f of x graph? So the period is going to be 360 degrees. What's number 2? The next question. The period of g. And the g of x graph, of course, is the tan graph. The time taken to complete one full cycle here. Period is going to be 360 degrees. And now not 360. 180. As you can see from start to end, it is 180 degrees. Okay. Time taken to complete one full cycle. Next question. Amplitude of f. And what's the amplitude? Amplitude is 1. It's measured from the middle, from the neutral to the maximum, and it's 1. Okay. Next. The range of f. The range is all possible y value. So it's going from negative 2 to 0. So y is greater than or equal to negative 2 or less than or equal to 0. Next. The domain of f. The domain is all possible x values. So if we look at this graph, the graph was drawn from 0 to 360. So the domain here, domain is 360 degrees. The domain and the period is different. The period is time taken to complete one full cycle, while the domain of the graph is the area or the coverage of the graph. Can you see that? The x values, all the possible x values of the graph. So if they ask you to draw the graph from 0 to 3 to 180, they ask you just to draw this part of the graph. What is the domain then? 0 to 180. Can you see that? But what would the period of that graph be? Still 360. Because why? The time to complete one full cycle is still 360 degrees. Even though they ask you to draw from 0 to 45. The domain will be 0 to 45, whilst the period, the time taken to complete one full cycle, is still 360. Does it make sense? The next question. F is increasing. So if we look at this part of the graph here, what do you notice? Wait, where's that? Look at this part of the graph, what do you notice? As you move from left to right, as x increases, what do you notice about this graph? It's increasing from there to there. Did you see that? From 90 to 270, what do you notice? Decreasing. From 270 to 360? Decreasing. Can you see that, people? So for which values of x is it increasing? Increasing. It's increasing for x is greater than 0 but less than 90 degrees. Or x is greater than 270 but less than 360. Okay. But if you look at 0, what happens at 0? Is it increasing at 0 or is it neither increasing nor decreasing? It's increasing. So at 0 is increasing. Let's look at 90. Is it increasing or decreasing here? Nothing. Why? It's turning there. Can you see here? The graph is not turning at 0. The graph is turning at 90. So at 90 is neither increasing nor is it decreasing. Can you see that? Look at 270. Is it increasing or decreasing? None. Why? It's turning point. Can you see that? At 360, increasing or decreasing? Increasing. Because this graph actually goes on and so on and so on. Can you see that? That was a nice question, eh? Next. So that's it. Okay. I need to take this off here. Number 2. Determine the equations of the following graphs. So 2.1. So as you can see, the equation y is equal to a plus a cos x plus q. So where do we start? Okay, we know this graph is actually moving half a unit down, and your a value is 1. Okay, I might be wrong. Okay, so what we do here, we start off by subbing yes 60 and 0. So let's substitute 60 and 0 into that equation, remembering that's a x and a y. So 0 is equal to a cos 60 plus q. Okay. So what is cos of 60? Oh, so you're going to calculate this. Or we know that's a special triangle. That's your 30, so 60 lies there, so it's 1, 2, root 3. So cos of 60 is adjacent of hypotenuse, which is a half. So it's a half a plus q is equal to 0. So q is equal to negative a half a. That's equation. We have 2 unknowns, so we're going to go into simultaneous equations. What do we do thereafter? Substitute 180 and negative 1.5. That's an x and a 1. So we're going to get negative 1.5 is equal to a cos 180 plus q. Cos of 180 is negative 1. That is negative 1. It says negative a plus q is equal to negative 1.5. And this equation. So what do we do now? We substitute equation 1 into equation 2. Wherever we see a q, we put negative half x. Okay? So it's negative 1.5 is equal to negative a minus a half a. So what's minus a minus a half a? Negative 1.5a. Divide both sides by negative 1.5. Therefore, a is equal to 1. So what do I do with that? I then substitute that into equation 1. Is it writing here now? So equation 1 now, so q is equal to negative a half times 1, which is negative a half. So what's the equation? Therefore y is equal to 1 cos x minus half. Okay? Number 2.2. They give us the basic cos graph, the basic of the stat graph. Huh? Did they give us the equation of this graph? No. Right. So the standard form of this equation should have been y is equal to a tan x plus q. Now, if you had done enough, the range of this graph, you can clearly see it's going to be y is equal to negative 2 tan x plus 0. Just negative 2. But say we didn't know that. What we do, we must use the information given. So as you can see here, it's going through 0 and 0. You see it's going through 0 and 0 there. So what we do, we substitute the origin's coordinate, which is 0 and 0. Remembering that's an x and a y. So 0 is equal to a tan 0 plus q. What is tan of 0? Check what tan of 0. 0. So 0a times it's going to give you 0 plus q, so q is equal to 0. So my equation now reads y is equal to a tan x And that's it. That's all. So what we do now? Now we can substitute that coordinate. And what is the coordinates here? 45 and negative 2. That's a x and a y. So negative 2 is equal to a tan 45. What is tan of 45? 1. So a is then equal to negative 2. So therefore y is equal to negative 2 tan. Okay? Number 3. In number 3 we are told that f of x equals a cos x and g of x equal to b sin x plus q are sketched. The question says, there's a question. We must determine the equation of the graphs. So, okay. So let's look at the f of x graph, which is this graph here. Okay. So how many unknowns are there in the f of x graph? There's one unknown, zero, a. So that means to say I just need one point on the graph to determine the value of a. Can you see that?
Mr. Bodine?
Yes, miss?
Jadely Duplessis, is she with you, sir?
Yes, she is.
Can you send her to the office with the bags, please, sir?
Okay, no problem. Okay, so we're going to substitute which point? Since it's on f, a point is lying on f. So it's 180 minus 1. Remembering that's the x and a y. So negative 1 is equal to a is cos 180. What is cos of 180? Negative 1. So that's going to give you negative a is equal to negative 1. So a is equal to 1. So therefore f of x equation is f of x equal to bye. People, we substituted negative 1 is actually positive 1. Not so? Which will result in a negative solution. Okay? Is that where I got negative 1 from? So I knew the equation is going to be negative cos x. So it's negative cos x. Let's look at the g of x. The g of x graph is b sin x plus q. How many unknowns are we need to solve here? There's two unknowns, b and q. So most likely I'm going to substitute 2 points in. Let's go with the first one. So the g of x, I'm going to go with negative 0 and negative 1. So you'll substitute 0 and negative 1. Remembering that's an x and a y. Alright, so that's going to be negative 1 is equal to b sine 0 plus q. What is sine of 0? 0, not so. 0 times b is 0, so q is minus 1. So my equation now reads g of x is equal to b sine x minus 1. So what do I do now? Substitute a different point that's lying on this graph, which is, you could have used either 270 and 0, or 360 and minus 1, or 90 and minus 2 is what I'm using. Again, that's an x and a y. So negative 2 is equal to b sine 90 minus 1. What is sine of 90? 1. Not so. Now what's 1 times b? b. Negative 2 plus 1 is negative 1. So therefore g of x is equal to negative sine x minus 1. Okay? Something like this normally worth 3 marks. 3 or 4 marks. Okay? But as I said, once you do a lot of these graphs, you can see from the graph what the equation is going to be. And you can just confirm it by doing the substitution back. That basically now brings us to 12C. That's it, okay. So what I'm going to do is I'm going to give you a chance to answer 12C, and then we will answer these questions on the board now, okay? I'll pause the video at this point. Okay, see, this is taking longer than expected, so we'll do this worksheet then tomorrow as a video, but you guys can conclude the work now, okay?